A ball is thrown at an angle of 30 degrees to the horizontal at a speed of 20 meters per second. Calculate its range and its maximum height reached. So, basically here, they tell us that it's thrown at 30 degrees, which would be like a try. We could try like that. And the horizontal speed is at 20 meters per second, so they give us here 20 here. Calculate the range and the maximum height reached. So here, this is a very. They told us that this is 30 degrees. And since they said this from the horizontal, they told us this was 90 degrees. And by telling us that, this here has to be 60 degrees. And this is a very special triangle because it's at 30, 60, and 90 degrees. So there's a very special rule that is this side here would be 2x, there would be x. This one would be 2x, basically twice as much as that one. And this one would be x times the square root of 3. So basically, knowing that we just said this is 2x, 20, and this is 2x, that would be 20 divided by 2, which would be 10. So x would be 10. And for now, that's all we need. We'll use the x times square root of 3 later. So they tell us what would be its maximum height reached and its range. So first, what we could do is see how high it could go, the height. And that would do by knowing that since gravity is 10 meters per second, and so every second it decreases 10 meters per second, that would tell us that 10 meters per second at the beginning, and later after just 1 second it would be at 0 because it decelerates completely. So here we gotta make the mean to know how much distance it is. So we do 10 plus 0, which is 5. And then we divide it by 2, which would give us... We do 10 plus 5, which is 10, and then we divide by 2, that's 5. So, let's see. 10 plus 0 is 10, and then this is 5. So now, we know that the height would be 5 meters. Because that's basically all for height. But then for the range, we're actually still need the horizontal velocity for one more thing. The only way to figure out range would be by figuring out the time. And to figure out time, it's easy because we just said here that it took 1 second to go to 0. And it would take 1 more second to go from 0 back to from this height reached back to the ground. So it would take us 2 seconds. So I'm just gonna write that there, 2 seconds. Then we're gonna have to figure out what x square root of 3 is. So what I would do is square root of 3. And then this we would multiply times x, which we said that was 10. So now this would be our horizontal velocity. So now this horizontal velocity, the only thing we have to do is, since this is speed, we just gotta multiply times time to give us distance. So we multiply times 2, which we just said that was time. And that would give us 34 meters. 34 meters. A ball is thrown horizontally from a cliff top with a horizontal speed of 10 meters per second. If the cliff is 20 meters high, what is the range of the ball? So let's make this a bit more interesting and say that there's this cliff, still 20 meters high. And instead of just seeing the range, we can 20 meters. instead of just seeing the range, we're gonna see if this ball could pass these spikes, which let's say they are 10 meters, and get to like the ocean or whatever, or will they hit the spikes? So what we would do is first we gotta figure out time, and that we would do by using the formula of S equals UT plus 1/2 AT squared. So we could substitute in U is basically initial velocity, so they say it's, and we're gonna figure out time, so this time we're not using the 10 because the 10 is horizontal, not vertical, so U would be 0. So 0 times time, whatever time is, that's 0. Then it would be still 20 meters as the distance, and we're gonna add it plus, no, not plus, it's just 1/2 AT squared, so 1/2 A. That A we said that's acceleration, and the acceleration by gravity is 10 meters per second, so 1/2 10 is 5. So 5 times time squared. So now what we would do is divide out 5 and say that 20 divided by 5 equals time squared. So basically 20 divided by 5, that's just 4. So that would will give us that 4 equals time squared. And what we do is make a square root in both. We make a square root of 4 equals time, and square root of 4 is just 2, so 2 equals time. So we're 2 seconds basically in the air before hitting the water, because we just calculated it. So next would be, with this time, figuring out how much of our horizontal would we go. So would our path, like here we have our ball, would the path be either going and falling the rocks, or will it be enough to just get to the ocean? So what we would do is we would use what we do is we would multiply our speed or velocity, which would be 10 because they tell us here, and that we would multiply it times our time, which is 2, and actually that's it. So that would give us 20, and that would be 20 meters. So the question of would it hit it or would it make it, well, it would pass it, and it would actually pass it in twice as long. You throw a ball at a speed of 20 meters per second. At what angle must you throw it so that it will just get over a wall that is 5 meters high? And then it would be how far away from the wall must you be standing. So let's say that you have this wall, and then there's a guy here. And you have this catapult, and you're gonna throw him a big boulder. And so, how do you make it so that you hit him if he's 5 meters high? So, the way we would do this is with a formula that would be, wait a moment, there. That formula would be v squared, which is final velocity squared, equals u squared plus 2as. So then, by knowing this, final velocity, since what happens when you throw it, it goes up. Then right at the highest point, it'll stop, and then it will fall again. So the final velocity will be 0. So let's just write that 0. And actually, here we're not using 20 as initial velocity, because what we're going to figure out is our initial velocity, actually, because we want to see how much velocity do we need to get just up enough, well, high enough, just high enough to get to 5 meters. So we don't know the vertical velocity, not the angular velocity. So v squared is 0, u squared is our cognita, so this would equal u squared plus 2as. Well, this one's easy because s is 5, so 2 times 5 is 10, and times 10 of acceleration is 100. So, yeah, well, yeah, 100. Technically, it would be negative 100 because acceleration is acceleration of gravity, and that's negative. So let's put that negative squared minus 100. So this one we can do by head, and we can figure out that u equals 10. U equals 10. So knowing that u equals 10, I'm going to draw a bit better. Knowing that u equals 10, we can figure out what angle we gotta have. So basically now we're going to draw a triangle. That's better. So we're going to draw a triangle, and we're going to say that the vertical one is 10. This angular one, they gave it to us, so that's 20. So then we've got to figure out what's the angle. So the way we would do it to figure out the angle would be by something that's arcsine, or arccosine, or arctangent. So that we would do is writing down so ka toa. This is just another thing to remember. And this word is divided into 3 parts: the so, the ka, and the toa. And basically we gotta choose one of these. So means sine of theta. Theta is just the angle. Equals opposite over hypotenuse. Then there's ka, which is cosine. Cosine of theta again. Equals adjacent over hypotenuse. And toa, adjacent over hypotenuse, and toa would be tangent of theta equals adjacent or opposite over adjacent. So now we would have to pick one, and we pick one by this part here. Then basically we need one with all our data. So we have, if this is the angle we're trying to figure out, this one here, this would be theta. So we know the opposite, which would be 10. This is the opposite, and this is the hypotenuse. So we need one with opposite and hypotenuse. That would mean sine. We'll have to use sine. So now, normally the way we would figure it out is moving it to figure out your opposite hypotenuse. But here we're going to figure out the theta, the angle. So what we do is we say that opposite over hypotenuse would equal sine of theta again, but to figure it out, we're going to use opposite and hypotenuse with arc sine. Basically, what we're going to do is put the opposite over the hypotenuse inside the arc sine. And arc sine is simply a sine. So let's put it. So that would be opposite, which would be 10 over 20. Well, that we don't need. That we can do by ourselves. That was 0.5. So then a sine of 0.5, and then we just calculate that. That's 30. So then we know that it has to be at an angle of 30 degrees. So here we know that this is the theta now. It's, well, 30. Theta equals 30. This one, since it's from the horizontal, this would be 90. And we can figure out that this is 60. So now they ask us how far away from the wall must you be standing. So this is basically how much would he have to move the catapult to either side to hit it just perfectly. So basically, this we would have to calculate with our angles, and well, they would calculate by doing the range. So let me just draw it a bit cleaner here. Our catapult or wall. Basically, the way we would have to calculate this is by calculating the range of the projectile. So basically we'll get a boulder here, throw it, hit the guy, hit the boulder, boom, hitting him, explosion, and then coming out here, the other side, coming out like this, saying that by hitting it, it didn't slow it at all. So what we would do is we would calculate the range, which is again just the distance traveled, and from the range you would just do half of it, because they say just the highest point, and the highest point is always at half of the distance. They say so we'll just get over. So yeah, so we do the range and then we do it divided by 2. So now we would have to figure out how to do the range. So range equals the horizontal velocity times the time. It's a really easy formula. We have the horizontal, well, we can figure it out, the horizontal velocity, because we have here two of the sides, but we need time. So let's, yeah, we got time. So time, we have to figure it out by knowing that the wall is 5 meters high, and the projectile is going to go, well, 5 meters high. So that would be that 5 meters. How much time would it take it to go all the way up to 5 meters and all the way back down? So the way we could do this is to see our vertical velocity. We see our vertical velocity would be 10. So since gravity slows it down at 10 meters per second, in 1 second it would go from 10. In 1 second it would go from 0. And in the next second it would go back to 10 in a negative direction. So that would be 2 seconds. So we know that t here t equals 2. Now we need to figure out what v equals, which is very easy. Because here, try it again, cleaner. So here we have another triangle of 60, 30, and 90. So again, this would be 2x, x, x square root of 3. And basically they give us x, 2x, and x. So we gotta figure out x square root of 3. So let's just put the square root of 3 and then multiply times 10, which was our x. And then again, just we multiply times 10. Equal, well, let me cut this. Round it up would be 17.32. So our answer would be 17.32 meters, because they ask us a distance. And that's it. Thanks for watching. Don't forget to subscribe and hit that bell.